teachers, and fellow innovators. We share a passion for solving a real-world problem through science and innovation. Our team believes that infrastructure should do more than just serve people. It should interact the environment, protect communities, and contribute to sustainability. That's why we developed our reusable biosponge road model, a revolutionary road system designed for absorbing water, avoiding blockages by purifying pollutants, and adapt to extreme weather while being eco-friendly and long-lasting. Each of us contributed to this project in unique ways. Some focused on the materials and designs, and others on technical analysis, and some on environmental impact and global applications. Together, we combined our skills to create a living, intelligent roadway that is more than just a structure. It's a step towards sustainable cities of the future. Today, we are excited to show you how our road works, why it is revolutionary, and how it can transform urban environments worldwide. I am Taufik, and our team is here to show you a revolutionary idea. A road that does far more than just carry vehicles. Cities today face floods, polluted water, and damaged infrastructure. Do you know what a conventional road may do in this type of situation? It will just let the water run off, damaging the streets and ecosystems. But what if a road can absorb water, avoid blockages by purifying pollutants, and protect the environment at the same time? That's what our project is going to prove. Yes, my role in this project was to shape the overall vision. I ensured that our reusable biosponge road model works together like a living organism. The top layer acts like a skin, controlling rainwater, and then the sponge layer acts like a stomach, purifying water by avoiding blockages. And then the tube and coil layer acts like a connective tissue and muscles, absorbing shocks. And finally, the mega pipe acts like a circulatory system, transporting clean water safely. Our team vision is simple but bold. Turns roads from passive infrastructure into active environmental guardians. Today, we will show you how each part works and how this system can protect cities, save ecosystems, and prepare urban areas for the future.
I am Afi, and we focus on the materials and aspects of this project. We wanted a solution that is eco-friendly, renewable, and regenerative. Every layer has a purpose: absorbing water, purifying pollutants, and stabilizing the structure. The sponge layer, for example, is filled with activated charcoal. This allows it to trap harmful chemicals, microplastics, and heavy metals, cleaning the water as it passes through. The jute and coconut coil layer support the sponge, absorbing excess water and preventing the roads from collapsing during heavy rain. I also worked on modular maintenance design. Each layer can be replaced individually without destroying the whole road. This makes the system long-lasting and adaptable. Unlike traditional roads, in short, our road is living infrastructure. It does not just survive from. It cleans, protects, and improves the environment. We believe this is the future of urban engineering.
I am Mohit, and I will explain the top two layers. The top layer might look simple, but it is highly engineered. It controls how the rainwater enters the system, preventing the sudden surges that can cause flood in streets. Its micropores and channels work as a smart skin, balancing the water flow and protecting the layers below. Underneath is the cellulose sponge layer with activated charcoal, which is the heart of the system. It absorbs water at incredibly fast rate while purifying it. Pollutants like chemical, microplastic, and oil are trapped here. Water enters messy and polluted,
but leaves clean, almost like a mini water treatment plant beneath your feet. Together, these two layers protect the road from heavy rains, reduces urban flooding, and transform chaotic water into controlled resource. This is where the infrastructure meets the environmental intelligence.
I'm Imran and I will explain the supportive layer. The toothbrush layer stabilizes the sponge, distributes weight and maintains its structure under heavy rain. It also allows water to pass naturally, resisting microbial decay. Below that is a coconut coil layer, which acts like a shock absorber. It allows water to flow into megapipe. These two layers work together like muscles and connective tissues, making the system flexible and durable. In extreme weather, the road absorbs the water instead of letting it destroy the street. This is where engineering meets biology. The road acts like a living organism adapting to rain, purifying water and maintaining its structure over time. I am Yusuf and I will explain the megapipe and the global impact. The megapipe is the final layer and carries the filtered water safely to the reservoirs, irrigation system and groundwater recharge areas. Because the water is already purified and the pipe stays clean and warm. The biosponge road is climate resilient and sustainable. It absorbs the flood, purifies the water and reduces the urban heat and protects the ecosystem. Its materials are plastic, jute, coir, sponge and charcoal are renewable, biodegradable and replaceable, giving the system a long lifespan. Imagine the cities where the roads do not just survive the storms. They collaborate with nature, clean the environment and regenerate the urban ecosystem. This is more than a road. It's an intelligent infrastructure system that helps cities worldwide to adapt climate change and protect the environment. That's why we believe in reusable biosponge road model represent the future of infrastructure. Now I will show how it's work. The water is being absorbed by the layers. After a few minutes, the water will come out through the mega pipe.
The water acts like a purifier. You can see the difference.
In conclusion, our reusable biosponge road model is not just a road, it's a living intelligent system that communicates with the environment to manage water, avoid blockages by purifying pollutants and protect the cities from floods.
By combining nature and sustainable materials like cellulose, activated charcoal, jute and coconut coir, our road absorbs stormwater, cleans it and ensures long-term durability. It's eco-friendly and adaptable, unlike conventional infrastructure.
The multiple layers work together as a living organism. The top layer controls water entry. The sponge purifies it. The mesh and the coil stabilizes and buffer. And the megapipe distributes the clean water safely.
This system works like this system transfers urban space, reduce environmental damage and prepare city to face extreme weather and climate change. shows what we can achieve in science. And our road demonstrates that can